the main goal behind all of the projects that I've worked on is to focus on this whole issue of control. So if a person has a disability, has a functional impairment, one of the biggest problems is that this person no longer has control of an environment, the work environment, the home environment, can no longer access things, can no longer turn buttons, can no longer get objects, can no longer actually move through the kinds of spaces that are just easy to do for people who have normal control and normal musculature. So if you have a stroke that affects, for example, the right side of your brain at a particular point over the sensory motor area, then typically your left arm and leg would be affected. My research focuses on the intersection or the area that is at the intersection of robotics and rehabilitation. So I am currently involved in several rehabilitation projects, and one of the main ones is called Feathers. It's to allow you to actually perform therapy that lets you regain your own muscle function so that you can regain that kind of control yourself.
How old are you?
11.
Sweet. How long have you been coming to therapy?
I think since I was a baby. I had a stroke when I was little and it affected my right side.
What we know about rehabilitation with these kind of clients is that repetition is really important, and so ideally that repetition has to happen outside of the clinic or even our home therapy setting. So the more that we can integrate this repetition into their daily lives in a way that's fun and meaningful for them, the better outcomes we're going to get in the long run.
So Feathers also, it's the idea that you are moving your hands and you're moving them in a purposeful way, in this case to run a game. How do we do that? We are doing that by having you control what amounts to be a virtual object. So this virtual object can be like a steering wheel, which you can only rotate, or it can be like a baton, which you can only move in this kind of motion, or it can be something like a mirror, so you have to do motions like this. Or we can develop other ways to do coordinated bimanual actions. But the goal is to develop the math so that the motions of two hands in one of these constrained ways all gets piped into the motion of one cursor.
Okay, so right here we have two PlayStation controllers, and the way we move right now is that you need to move both hands in the same direction at the same time for the cursor in the screen to move. This, so I can go left and shoot, right and shoot. But if I just move one hand, nothing happens. So as you can see, we're applying the principle of bimanual movement into this gaming interface.
So we're taking that idea that bimanual control is a good construct in order to regain function of the weaker side. What we then want is we want to develop a robot that people hold on to, and the robot itself is wearable, therefore, and it provides either forces back to you that can help assist you or resist you, or it can provide vibrations or various other senses back to you.
I'm designing the physical interface of the project. I'm designing the controllers themselves. And studies have shown that babies by the age of 12 months are already pointing with their index finger to communicate. That's why I have designed it so that with the position tracker facing forward in sort of like a power grip position for the hand, so that this would allow the user to intuitively control the cursor. And this way, that also allows the physiotherapist to prescribe different kinds of movements for exercises, so that the hands could be in this position and the controllers would be pointing towards the screen in this position and also in this position.